Okay, here's your homework checker for Monday, February 5th. First question is 549 divided by 7. So we're asking ourselves, how many times can 7 go into 549? So if you're solving partial quotients, this is what it'll look like. You make your cheat sheet, so you fill in all of your factors. This is just getting your brain warmed up for how many times 7 can go into 549. And so we're getting this all ready. So when we look, I see that 7 can go into 549 at least 50 times. So 50 groups of 7 is 350. So we subtract that out. 9 minus 0 is 9. 4 minus 5, got to borrow for that one. So 14 minus 5, 14. 13, 12, 11, 10, 9. 4 minus 3 is 1. So now I ask myself, how many times can 7 go into 199? Well, I see here it can go in 20 times. So 20 groups of 7 is 140. Subtract that out. 9 minus 0 is 9. 9 minus 4, 9, 8, 7, 6, 5. 1 minus 1 is 0. So now we're to a friendly fact. We ask ourselves, how many times can 7 go into 59? And so hopefully you're knowing your facts off the top of your head, and you're thinking 7 times 1, 7 times 2, 7 times 3, and I can go all the way up to 7 times 8, which is 56. So 59 minus 56, 9, 8, 7, 6 is 3, 5 minus 5 is 0. So I have a remainder of 3. Now I can add these up. 50 plus 20 is 70, plus 8 is 78. Can't forget my remainder of 3. Now if you're solving this traditionally, it's similar steps. You cover up all your place values except your hundreds. How many times can 7 go into 5? Well, I can't do that without moving over my place value. So, how many times can 7 go into 54? That's going to be 7 times. So, 7 times 7 is 49. Subtract that out. Got to do some borrowing here. 14, 13, 12, 11, 10, 9. 1, 2, 3, 4, 5. 4 minus 4 is 0. 7 can't go into 5, so I bring this down. How many times can 7 go into 59? 8 times. 8 times 7, 56. Subtract that out. I get 3. 7 cannot go into 3, so it's a remainder. Make sure you're showing your work. Next question. Complete the chart to find the factors for each number. So we're finding the factors, and then we're going to find the GCF, the greatest common factor of 48 and 21. So let's do that. Let's show our work. 48. I know I can go 1 and 48 times. 2 times 24. 3. Can 3 go into 48? So you're thinking to yourself, yes, it can. 3 times what? Let's see. I can't use my multiplication chart because it's not on there. So I have to do what's called a guess and check if I don't know. So if you don't know this off the top of your head, you can start with numbers that you think are close. So let's start with 16 times 3. 3 times 6 is 18. Carry my 1. 3 times 1 is 1. Plus 1 is 4. So 3 and 16. And if you notice the pattern, 24 is half of 48. 16 is half of 24. Well, just kidding. It's not. But there is a pattern. So then we have 4 and 12. There's our half of 24. And nothing times 5, something times 6, 6 times 8. So a lot of factors for 48. Now we have 21, 1 and 21. Nothing times 2 because it's not even. 3 and 7. And that's it. So now we circle our ones that they have in common, which are 1, 3. That's it. So the GCF here is 3. Next question. There were 7 boxes of cupcakes. Each box had 12 cupcakes. If the 4th grade ate 60 of them, how many were left over? So this is a multi-step word problem. We have to know what information it's giving us and what to do with that information. So it says 7 boxes of cupcakes. Each box had 12 cupcakes. So we have to figure out how many cupcakes there are total. Then we have to subtract the 60 that were eaten. So let's solve these steps. Alright, I got my 7 boxes of cupcakes, and then there's 12 cupcakes in each of these. So when you're thinking of a computation, you can add all of these up, or you can do 12 times 7. 7 times 2 is 14, carry my 1. 7 times 1 is 7, plus 1 is 8. So there's 84 cupcakes total. But I'm not done because it tells me that 60 of them were eaten. And I have to figure out how many were left over. So I take my 84 and I subtract, 84, and I subtract my 60 from it. So 4 minus 0 is 4. 8, 7, 6, 2. So there's 24 cupcakes left over. Best answer? A. Alright. Which is equivalent to 2 divided by 12? So, I'm trying to think of another way I can write 2 divided by 12. So, 12 minus 2, nope. 12 times 2, nope. 12 over 2, 2 over 12. So remember, these can also be read as division statements. 12 divided by 2, or 2 divided by 12. So which one says 2 divided by 12 as a fraction? That's D. Which fraction is simplified from 3/12? So we have to take 3/12 divided by the GCF and see what it is in simplest form. You can do that using your multiplication chart as well. So you find 3/12. There it is. The GCF is 3. So 3/12 divided by the GCF. 3 divided by 3 is 1. 12 divided by 3 is 4. So 3/12 can be reduced to 1/4. So if I look at my multiplication chart again, here's 3/12. Reduce it all the way down, boom, 1/4. So my best answer here is D. What is 1/6 plus 1/12? So when I'm noticing these, I know I'm adding fractions, and I notice the denominator is different. So I have to figure out the common denominator so that I can add these properly. So I set up my formula, 1/6 plus 1/12. Well, the first step is to skip count and find my new denominator. So let's skip count by 6. 6, 12. Boom, I can stop because look, when I skip count by 12, I say 12. So my new denominator is 12. So then I asked myself, how did I get from my old denominator to my new denominator? How did I get from 6 to 12? And the answer is right here. I multiply by 2. So 2 over 2. So 6 times 2 is 12. 1 times 2 is 2. Now, how did I get from 12 to 12? Answer's right here. Multiply by 1. 12 times 1 is 12. Put 1 right here. 1 times 1 is 1. So now I'm adding up 2/12 plus 1/12. So my denominators are the same now, which means it's going to be the same in my answer. 2 plus 1 is 3. So 3/12 is my answer, but I should not finish there. I have to ask myself if 3/12 can be reduced. If I look up here on my other question, I saw that 3/12 can be reduced. The GCF is 3, and so it can be reduced to 1/4. So 3/12 divided by 3 over 3. 3 divided by 3 is 1. 12 divided by 3 is 4. Can be reduced to 1/4, which is my best answer. So when I look over here, I see that it doesn't even have 3/12 as an option. which means I have to reduce. So the best answer here is C, 1/4. All right, our social studies questions. Which word means someone who doesn't want slavery? This is a person who supported their freedom. Was it A, general, B, secede, C, abolitionist, or D, Confederate? Which one of those people did not want slavery? An example is John Brown and Harriet Tubman and Nat Turner. Number 2, which word means someone who is in charge of a unit of soldiers? A, general, B, secede, C, abolitionist, D, Confederate. So an example of this person could be like Robert E. Lee or Ulysses S. Grant. Number 3, which word was a nickname for the South? This is what they called the southern states during this time period. A, general, B, secede, C, abolitionist, D, Confederate. Number 4, which word means to leave? Kind of like migrating, but you're not with a group anymore. A, general, B, secede, C, abolitionist, D, Confederate. All right, make sure you're showing your work.